Hello and welcome to this first video of a series of videos where we walk through example workflows which we can do with Project Succession. Project Succession is a pipeline automation tool I'm currently developing, and I want to show you where we currently are, what we can do, and where the journey can go. For today, we will make an image generator, or not only an image generator, but actually a game sprite generator. We use nanobanana from Google for the actual image generation, and we can then process the generated image further to make it usable sprites. The very first thing we want to do is go on to nanobanana in Google AI Studio, and up here we have the Get Code section. This actually shows you the code of a REST API. It might be by default on Python or on TypeScript, JavaScript, but what we are interested in is the actual REST API call. Because we are going to do exactly that in Project Succession. Project Succession has a bunch of different triggers. You can basically trigger workflows on almost, not every event, but a lot of events going through. Some events are fired from third-party DCCs. Others might be scheduled or on file system change, or just a set interval. You could also set up a Slack bot, which when you mention a Slack bot, it actually triggers a workflow. Or you could use webhooks to trigger workflow. What we will do now is we will use a simple onStart trigger, which basically triggers automatically as soon as we execute the workflow. The next thing we want to handle is we want to build an HTTP request calling that code here, right? So for that, we have an HTTP request action node. And what we can already see here is that we actually do a post request. So we can switch that here to post. And then we need to find our headers, body, and URL. So all of that information is also in here. Our header is this part here. This is a string though, and Project Succession requires a JSON struct. So what we want to have here is we copy that, and then in the header we define a JSON struct, we paste it in, and we need these to be individual strings. For the body, we do exactly the same. Our body is what comes here. In this case, Google actually passes in a file, a request.json file, which it defines up here. I actually want to make it a little bit more clear if we type in hello world, but don't send the message yet. And we type in get code again. We have here in the parts an actual text hello world, and this is what we will replace with our prompt. For now, we can copy that JSON and paste it in here. So this will be our body. And last but not least, we need our URL. Our URL is in the section, this thing down here. So we copy that too, and we paste it up here. So there are a few considerations though. This will not run out of the box. And why is that? Because Google makes use of a few things here. First, it defines variables, which it then uses later down the road, as you can see here or there, and we don't want that. Well, we also want to define variables, but to handle variables properly, we need to define them a little bit in project succession. And the second thing is it also returns text and has a hard-coded prompt. So all of that in the end is just string values, right? This is just base text which we are handling here. So what we can do, instead of putting everything into the HTTP request node directly, we can use a string manipulation node and take the string we have here, copy it in there, and replace certain things with incoming information. So we can hit the replace mode, and in our text here, we define a variable here we want to replace. This is just string replacement, so you could also say I want to replace hello world with something else. But in our case, what we want to do is we want to have a very distinct variable naming, so like batch script would also have. So what I do here in this case is I just use the bash script syntax to insert a variable, and I call this variable prompt data. And then I copy that entire variable out without the quotes, and I find that text in the string, and in here we can now put in our prompt. And then our prompt will actually be inserted at that certain position. What I also want to do is I want to remove the text output. We only want images to be returned. So this here will now be our body. We can pass it in here. The next thing we probably want to have is another string manipulation to define our link, because our link also has a few variables in there which we want to replace. Let's do another string manipulation node. And this will be our URL. So we copy that in here. And we connect the output of this string manipulation to our HTTP request URL. We want to replace again. And the model ID and the generate content API can be the same always, so we don't need variables for those. We can just copy them out here. This is the model ID. And the generate content API is the stream generate content. Like this. This link now only has one variable left. And this is what we want to replace here. So, how do we get this API key? Project Succession has a secure vault which attaches to the default operating system vault system. And you can find it under settings. And if you scroll down, you find here the vault section. The vault has a lot of different keys. I'm not going to show you all the keys, but you basically see here it uses the operating system's keyring. So in case of Windows, it's the Windows Credential Manager. I think in case of Mac, it is actually called keyring. But we can now copy that key we provided. And when we use a load secret node, we can actually load a certain key directly in the runtime of our program. By default, nodes might have access to these secrets. So if a node requires a certain secret, you can just pass it in directly in the node. The problem is our HTTP request doesn't have such a mode, and our string manipulation node also not, because these are very generic nodes which usually don't handle with secrets. Also, Google requires us to have the secret within the URL and not like attached in a header or somewhere else. But for that, we actually need to load it into the workspace. You see this little warning sign? This means that at this point we danger to expose some of our secret data. Don't worry, this will not be saved or serialized into the generated JSON of the image generator. Here you can see this is how our graph looks. Where you see this is our string manipulation node with find text and replace text, right? So all of the data here is just saved for project succession to execute. And there's no API key saved whatsoever because this still runs through our secret provider and through the operating credential manager. But we need it here available to build that URL. So we actually need to load it. We can load it though, and it might be exposed if we choose to log it here, for example, right? If we do a log, obviously then this will be exposed in logs. And if you save out that log somewhere, or if you save out that output somewhere, it might also be saved. So this is why there's a warning. But we actually replace our variable Gemini API key with our actual Google API key value here. We also can use a provide string node here as our prompt. So this will be going in there. And we call this our prompt. So HTTP request now has everything it needs. It has the URL, it has the prompt and the body, it has the header, and it has the method. It will not run though still. We can actually try it out real quick, and it will provide you a builder error. This is because things coming out of the string manipulation node are strings by default. And what we now do with putting in these little quotes in the beginning and the end is basically having double strings. And this doesn't really work in terms of an HTTP request. So we can safely remove them here, left and right. And what will now happen when we execute the HTTP request will generate an image and return us a base 64 string in a large data structure for us to save to disk. So how does the data structure actually look? We can use our log function here to return our response body. This will become very, very slow because the base 64 string is huge and the UI might have a little bit of a hiccup when actually displaying the whole string. So, but let's do it anyway. And we see currently there's no image, pretty sure because there's no prompt. So let's provide a prompt for this. Sprite sheet of a medieval fantasy RPG RPG icons, no icon background, vibrant colors, black background. Yes. So now what happens, since we have now a proper string input prompt, it should generate us an image. And you see we get a huge base64 string back, and Project Succession actually struggles to display that entire data, as you see. I think I will actually return like a display maximum on the log node because this is like really unusable. Let me know if you prefer rather some hiccups or and the full data or always just the a stable UI and therefore a little bit of truncated data when it's too big. Um, but we can now use the data selector node to actually isolate that entire string because you see it is in a data structure hidden below. So if we now use a data selector node, we can walk this data structure. We see we start with a list and we want the first list item. So we just type in 0 as a list index. And when with forward slashes, we can walk down the data structure. The next thing is candidates. And this is a list again. So we select the first index. Then we have content, parts. This is again a list, first index. And then we have the inline data and the actual data. So this little string here will now actually isolate our data directly on the top level of our pass data. We pass it in here and let's delete the log and our graph is responsive again. Nice. But now we have this string, this raw base64 string. To now get this string to be saved on disk, we first need obviously a path where we want to save it. And secondly, we want to have a node which actually can save that data. Luckily, Project Succession also already has this kind of node available for us. So we have save image from data, where we can put in raw image data here. This image data by default is base64, but it could also take in actual pure byte data. We allow overwriting, so in case that file already exists, we want to just overwrite it. And in case the directory doesn't exist, we will actually create the directories. So we have always a full path available. But what will now be the output file? We can use our working directory node to get an OS starting point, which starts in that folder here. So it's the desktop succession pipeline folder, and we get this directory out there. It's the working directory or file. The file path is the actual JSON file, but we want to use the directory only. We can now say, okay, our directory should obviously have a path to not only be a directory, but an actual file path. And for that, we choose the directory as a base path. And then we say generated image.png as the actual save path. Let us generate that image now. The HTTP request generates the image and then it saves it here. And you can see we have a bunch of sprites of medieval looking icons. Very generic, but it seems to work. The next thing we want to do is we want to remove our black background. We can do so by using the remove background node. And you see project succession has a bunch of background and a bunch of image processing nodes built in already. This comes just from the need of them, because you often also want to manipulate data on the fly and not always rely on a third-party program. But obviously you could do all of that also with our large list of Photoshop nodes. In this case, project succession would connect to a running Photoshop instance and use that Photoshop instance to open an image, process it in Photoshop, save it out. Like this all could work too. In our case though, we use direct image processing. We want to remove our background, and we have here our save path, which we want to use as our source file. And we do a string manipulation node to again replace our original path our original file name with wait a second, we don't want this here. We want to say, okay, we want to replace that file name with another file name. And that will actually give us now the output file name. If we just run this by default, we will now get, instead of one image, two images, one generated image and one no background. And you see the no background has the background removed smartly, but way too aggressively. It's using differences in color, basically an edge detection mode, but our threshold is at 128, which is like 50%. That's way too much. Let's turn that down to something like 12. Allow overwriting again and execute once more. And now our icons look way better already. They have some nice laid out cuts where we just remove the black background. And this is already pretty cool, right? But we can go one step further. Because Gemini by default comes with this awkward padding at the end, we don't really have our sprites centered. So if we now cut them into a sprite sheet, we have this little padding at the side, and and then we might lose some of the detail here. I find it funny how ChatGPT basically puts in, not ChatGPT, Gemini puts in the same sprite multiple times, or very similar ones. But this is something you can tweak with the prompt, I guess. But to process it further, to not have this awkward padding and to actually have everything laid out correctly, we now can use a detect sprites node where we find the output directory and the source file path. So the source file is obviously our nodebg. We will allow overwriting again. And as our working directory, we just get it again real quick here. This is what we use as our output directory. Let's execute that again. And once this is finished, we get all of our individual sprites saved out as individual sprites. So we have very small ones here, and we have a few bigger ones. This is not the behavior we want. So let's actually delete them because it's having a minimum sprite size of just 1 pixel. That means as soon as a pixel is isolated, it treats it as an individual sprite. But we don't want that. So we set a minimum pixel size to 50 for our sprite size. And that will now detect the sprite way more accurately. As you see here. Here, we still sometimes have a weird behavior, right? This is like obviously not a good sprite to cut because it kind of detects this as one individual and this is one individual. You see them here. But in general, we have very good results, whatever this here is. And again, we have duplicated and very similar sprites. I think this is just Gemini not working well with the prompt. Because you can also see it here. We have the same thing twice in here. Very similar sprites here and there, right? So I wouldn't really trust that to come out by default with just a little prompt. You need to put in some more work for the AI to properly generate what you want. You can also do an individual HTTP request per icon and then just get one icon out. Then you don't need to cut them. But now that we have our sprites actually isolated and cut down nicely, we can combine them back into a sprite sheet. Images to sprite sheet. And we put in our source images, which we get from here. And we output that into no, we do not path info, but path join. And this will be our sprite sheet. PNG. And our sprite sheet should have 4 columns and should allow override. And now if we execute that, we don't fully execute. Let's see where it actually stops. This is a bug in project succession, which is known that sometimes if we branch off too much, here we see this, then it loses the main execution line. This will be obviously solved when we have it released fully. But I think the solution here is instead of using that get working directory up here, we just use the second one here. So this, while this bug exists, it doesn't have the biggest priority right now because it's easy to work around by just introducing another node at a certain point. And now everything runs through. And we have our generated image, our no-bg image, all our individual sprites, and we have our sprite sheet, which properly maps all of our textures together. These are a lot of sprites though. Maybe say we have 8 columns instead to have a little bit more square image. And let's try it again. Nice. And here we now have our sprite sheet with some very good setup. And this is where we stop for today. It's not the end of that workflow, obviously. The next thing we could do is we could say, could use a Unity node, which basically would be an import into Unity. And there you would basically put in a relative Unity path of the running Unity project. For example, assets, textures, sprites.png. And then we could do an apply Unity preset, where we select again that path, and I don't know, like sprite preset dot asset. I think would it be to actually apply a certain import preset for that sprite sheet. And with that, you would automatically have an access to the textures in Unity directly. And that's it. I hope you like it. If you want to follow Project Succession further, please follow my Discord. Link is in the description. And like, subscribe, all the other things you probably won't, because this channel here is not necessarily super entertaining, but more informative over what I do in my time working as a technical artist, software developer, and yeah, I think, sorry, I need to come to an end. See you around. Cheers.